Hello everyone, my name is Homero Aradi. I am a student for the class Biostatistics for Health and SPSS with Dr. Manuel Cifuentes. This recording is going to have two parts. This is going to be part one, and I want to explain that during my presentation, that is going to be student two, I'm going to talk about statistical models. And I'm going to explain statistical models because that's my experience in laboratory analysis with chemicals. We use a lot of statistical models, specifically linear models, and that's what we're going to be focusing here. So this is going to be an introductory presentation for those of you that have not clear what a statistical model is, or how can the statistical model is applied. I want to say that we're going to go through some of the concepts that are important, and then we're going to show you a little example of how to use and how to operate with linear statistical models. So, what is a statistical model? And how it is considered. So I went to the references and I found Konishi and Kitagawa in 2008. They said that a statistical model is a crucial issue in scientific data analysis. Models are used to represent stochastic structures, predict future behavior, and extract useful information from data. This is an important information, and a concept that I made up is a defined criteria. Statistical model is a defined criteria built from consistent real-world collection of information or phenomena that allow us to explain a theory or things and infer explanations from further observations. That means that we have to keep collecting information in order to fit the models, and that's the big challenge that we have in modeling, because we cannot trust everything to the models. Anyway, so why do we need a statistical model? So basically, it's to infer explanations based in observable data. But when we say infer explanations, we also want to be careful and have to say that we only are going to infer explanations if we have a good fit in our model. So it is also important to know how well does a model fit, because not information is the same, or probably the model is not accurate for a specific thing. So that's an important point in statistical modeling, and here I just have the list of what are the ways that a model can be fit, and there's good fit, there's moderate fit, and there's poor fit. And poor fit could be either for the quality of the data or the number of data that have been collected to fit a specific model. And I have to say that basically models are fed by a lot of information, so it really represents the population, a population. And so we're going to talk about linear models and statistical linear models, and the linear models are basically models based in a straight line and the information that is based in the line. So the equation of the line is y equals m times x plus b, while m is the slope of the line. And from this, it's really important that we are clear and sure what is the independent and what is the dependent variable, because that will change the meaning of our research. So this is the explanation. This is part one, and I'll come back. Please check part number 2. Thank you very much.